You know, we are absolutely surrounded by computers, way more than you probably think. In this explainer, we're going to peel back the layers of technology, taking a journey from the room-sized giants that predict our weather, all the way down to the invisible little chips that basically run our lives.
So just take a second and look around you. How many computers are actually in the room? One? Two? You're probably counting your laptop, maybe your phone. But I'm willing to bet that by the end of this, you're going to have a very, very different answer.
To figure out that real number, we're going to go on a journey of scale. We'll kick things off with the absolute giants of computing, then scale it down to the professional workhorses, then to the devices we hold in our hands, and finally, we'll uncover the hidden, invisible computers that are literally everywhere.
Okay, let's start at the top. Let's talk about the giants. And I don't just mean big computers. These are machines on a scale that's, well, it's hard to even wrap your head around. They're built to solve the biggest, gnarliest problems we have.
Right at the very top of the pyramid is the supercomputer. The best way to think about it is like a Formula One race car. You're not going to use it to drive to the grocery store, right? It's built for one thing and one thing only: absolutely mind-bending speed for tackling one single incredibly complex problem. And the stuff they work on is just wow. Their speed is measured in something called petaflops. That's 1,000,000,000,000,000 calculations every single second. That's the kind of insane power you need to predict where a hurricane is going to go, or simulate the birth of a star, or even design a new drug. We're talking about legendary machines like Japan's Fugaku or the USA's Frontier.
All right, next up in the land of the giants is the mainframe. Now, if a supercomputer is a race car, a mainframe is more like a massive cargo plane. See, it's not about the top speed for one task. It's about unbelievable reliability and handling a huge volume of things all at once, 24/7, without ever stopping.
And this slide just nails the difference. The supercomputer is a sprinter, all of its power focused on one gigantic problem. The mainframe, it's a marathon runner. It's handling millions of your credit card swipes, your ATM withdrawals, and your flight bookings all at the same time, and it doesn't even break a sweat. So we've seen the giants, but what about the layer right below them? Let's scale down a bit to the professional workhorses. These are machines designed for really specialized, demanding jobs.
First up, you've got the mini computer. Yeah, the name's a bit of a throwback now, but they were a super important step. Kind of like a bridge between those room-sized mainframes and the desktop computers that came later.
And then there's the workstation. Now, this might look like a regular desktop PC, but trust me, under the hood, it's a completely different beast. Think of it like a PC that went to the gym every day. It's supercharged with high-end processors, tons of memory, and monster graphics cards for pros who need serious horsepower. So, who needs that kind of power? Well, think about the animators at Pixar rendering a new movie, frame by painstaking frame. Or the architects designing an entire skyscraper in 3D before a single brick is even laid. A normal PC would just grind to a halt. But for a workstation, that's just another Tuesday.
Okay, so from those professional powerhouses, we're now going to scale down to the computer that really, truly changed the world. The one you're probably most familiar with, the microcomputer. A microcomputer sounds all technical, doesn't it? But it's just the official name for what we all call a personal computer, or a PC. These are the machines that brought computing power to the masses. Affordable, compact, and easy enough for all of us to use. And they are just everywhere. The desktop at your office, the laptop in your backpack, the tablet on your coffee table, and yep, that little supercomputer in your pocket that you call a smartphone. Every single one of them is a microcomputer.
All right, so we've covered the computers that we can actually see, but now we get to the really interesting part, the ones we can't. This is the invisible revolution, the computers that are fighting all around us, right in plain sight.
So let's go back to that question I asked earlier. What on earth do your car, your microwave, and your smart TV all have in common? They seem like totally different things, but they're all sharing a little secret. And the answer is the embedded computer. These are tiny, single-purpose computer chips that are hidden inside countless other devices. Your modern car probably has dozens of them, controlling everything from the engine to the radio. Your washing machine has one, telling it how to run the cycles. These are the real computers hiding in plain sight. And then we have this fascinating blend of two different worlds, the hybrid computer. It's basically a translator. It takes continuous, real-world data, that's the analog part, and turns it into clean, simple numbers, the digital part. The perfect example is an ICU monitor in a hospital. It measures the continuous wave of a heartbeat and displays it as a nice, clear digital number on the screen.
And real quick, we should give a shout out to their ancestor, the purely analog computer. Instead of ones and zeros, they worked with physical things, like the needle on an old speedometer. They're pretty much history now, but hey, they were the pioneers.
So, wow, we've gone from computers the size of a bus all the way down to chips you could lose in your pocket. Let's put this all together and look at the whole spectrum of computing.
This chart lays it all out beautifully. You can see the whole ladder, right? From the highest power level for global research, down to the massive enterprise machines, down to the professional's desk, down to you and me, and finally, all the way down to the tiny embedded chips that run everything else. It was never about which one is best. It's about having the perfect tool for every single task.
And I think it all comes down to this one simple, powerful idea. From massive supercomputers that simulate galaxies to tiny embedded chips inside everyday appliances, computers exist in many forms, each serving a unique purpose. So let's go back to that first question one last time. How many computers are in the room with you right now? I'm guessing the answer is dozens, maybe even hundreds, and most of them are invisible. We've seen the whole family of computers as they exist today, which leaves us with one final fascinating question. What's next? Is it going to be quantum computers solving impossible problems? Or will computing become so woven into the fabric of our world that we just stop seeing it altogether?